At the beginning of chapter 18, I told you one of the reasons why I liked this chapter was because amines are found in most drugs, pharmaceuticals as well as illegal drugs. And I, as a chemist, I'm very fascinated with pharmaceuticals and illegal drugs. And so what we're going to talk about next is definitely one of the coolest things I think you learn in this class: ammonium salts as useful drugs. So the ammonium salt is the product that you get when you react an amine with a strong acid, which was the last reaction that we looked at. An amine plus a strong acid like HCl or HI. The product of that reaction, where you have the nitrogen that has the extra hydrogen and the positive charge, that type of molecule is called an ammonium salt. Many pharmaceuticals are ammonium salts. This is especially true for over-the-counter. So especially your over-the-counter OTC, many pharmaceuticals are these ammonium salts. And so if you actually get up right now and go look at your medicine, like your cold medicine or your flu medicine, you're going to find a lot of ammonium salts inside those jars, those bottles and boxes and things like that. So here's one example of a medicine that you might have. Well, the first thing we're going to draw is actually not a medicine that you'll have. Probably don't have this. So this is a molecule that has quite a bit of functionality to it. It's got several functional groups. It has an aromatic ring, it has an alcohol, it has a secondary amine. This molecule is called pseudoephedrine. It's famous because it is a really good precursor for methamphetamine. So pseudoephedrine is, because it's an amine, and this is one thing we haven't talked about, amines in general have a really bad smell to them. And pseudoephedrine is no exception. So this thing smells like, I don't know how you would describe it. Amines generally smell like bad fish. So maybe we'll say it smells like rotten fish. A lot of the bad smells that you encounter in your world are amines. So decaying organic material, dead thare rotten food, urine, especially when it smells nasty. Those bad organic smells that you're smelling are almost always amines. So ephedrine smells like rotten fish, and it is not water soluble. Ephedrine is, though, a great cold medicine. So this is an excellent decongestant. But the average consumer isn't really stoked on taking pseudoephedrine for their cold because it smells really funky, and people just don't really want to put it in their mouth. So pharmaceutical companies know that if they react this amine, this pseudoephedrine, with a strong acid like HCl, and HBr is also used very commonly in the pharmaceutical industry, we're going to get that reaction that you just learned where we have our amine and nothing changes on the structure at all. So it's not going to lose anything. Everything is still going to be there. And then we add an extra hydrogen to the nitrogen, and that leaves us with this Cl minus. This that we just drew, this is the ammonium salt. So all of this right here is the ammonium. That's a generic name. Ammonium salt applies to a lot of different molecules. That's what it means to be a generic name. The technical name for this combination, this thing that we just produced, is pseudoephedrine HCl. And maybe there might be a dot in between the pseudoephedrine and the HCl, but that is the technical name. It's indicating that the pseudoephedrine has been reacted with HCl. The brand name for this combination is called Sudafed. So if you have Sudafed at home, and I mean like real Sudafed, like the kind you have to ask the pharmacist for, not the Sudafed PE that you can buy over the counter, that's a different molecule. So this is real Sudafed. If you look at it, you'll see it's pseudoephedrine HCl. And the great thing about pseudoephedrine HCl is that when we add the hydrochloric acid to it and we convert it into this molecule, it loses its stink. It has no smell. So that makes it much more consumer friendly. And also it's soluble in water. It changes its solubility, which makes it a little bit easier for us to consume. The negative, though, is that because it's not pseudoephedrine anymore, we have converted it, it doesn't respond quite as well in our body. So it doesn't do quite as good of a job as if we could take just pure pseudoephedrine. But as you know, probably, because you've probably taken Sudafed, it does a really good job. And like I said, most of your over-the-counter medicines, particularly your cold and flu medicines, cough medicines, and decongestants, if you look them up, you're going to see a lot of active ingredients that have a name that's similar. It's not similar to the pseudoephedrine part, but it's going to have HCl at the end of its name, or maybe HBr at the end of its name. And that's indicating that it is an amine that has been converted to make it more consumer friendly in terms of its smell and its solubility. Another place that this is used a lot, not in the pharmaceutical industry, is the cocaine/crack industry. And this is fascinating stuff to me. So I'm gonna talk a little bit about cocaine and crack. Cocaine. We're not going to draw the structures of cocaine and crack because they're actually really big and complex molecules. So the first thing that we have to clear up here is the true names of these molecules. So when I say up here cocaine versus crack, this is the street name. Like if you went up to somebody at a 7-Eleven and said, "Buy me some crack, sell me some crack." That's what I'm referring to. The true name of crack, like if you go buy crack, that is actually cocaine. So this is the chemistry name. And isn't that weird that what we call crack on the street is actually cocaine? And the chemistry name of cocaine, if you go buy, like, hey, sell me some cocaine, what you're getting there is cocaine HCl or cocaine HBr. Oh, it's usually HCl because HCl is easy for us to buy. Easy for people to buy. Not incriminating myself. So the crack molecule, which is technically called cocaine, this is the natural form of the molecule. So this is the form that is extracted from the plant, which also is funky because we think of crack as like a dirty kind of processed drug, which is true. By the time it comes back to you, the user, as crack, it's been through a lot of different reactions and processes. But crack is a reflection similar to the pure molecule that's extracted from the plant, whereas cocaine is synthetic. When you buy cocaine, it has been altered. It is not made in a plant. The crack, whatever, the pure cocaine, real cocaine, gets extracted from the plant, and because it's a pure amine, and it's actually a tertiary amine, it smells bad. It's got that amine smell to it. And it's also not soluble in water like amines. Because it's not soluble in water, if you want to get high off of crack, technically known as cocaine, if you want to get high, you can't absorb it through any of your mucous membranes, meaning like it's not very effective if you snort it. What you really need to do is smoke it. Because it's not water soluble, so getting it into your bloodstream is quite a bit more difficult because it just doesn't want to go into your blood, which is very aqueous, very full of water. So crack that you buy is smoked because it's not water soluble, and that's the most effective way to get high off of it. Cocaine, or cocaine HCl, the synthetic form of the drug, is not a pure amine. It's one of these ammonium salts. Because it is this ammonium salt, it doesn't have the same type of smell, so it's not super stinky. It could be stinky if it has been altered in the manufacturing process, depending on what's been put into it, but it shouldn't smell bad. It should smell good. And no, it should smell nothing. And it is soluble in water. Because it is soluble in water, that means you have more options of how you can take cocaine. So classically, it is snorted up the nose, and then it absorbs through your delicate mucous membranes into your bloodstream, where it eventually goes up to your brain, which you can't snort crack for a variety of reasons, but one of them is that it just wouldn't work. It's not going to get you high if you go that route. So the problem with cocaine and crack, because crack is the pure form of the molecule, this stuff gets you a real nice high. Nice and high. Whereas cocaine is not the same high. Because cocaine is not, cocaine that you're purchasing, cocaine HCl, is not the same as the drug that Mother Nature has made. So the high is just not, it's good. I hear it's good, but it's not as good as the high that you would get from crack. So a lot of times on the street, people buy cocaine because it's a little bit easier to purchase. It's a little bit easier to smuggle, but they will convert the cocaine into crack. So convert cocaine, what you would call cocaine, into what we would call crack. Because the crack is just a better drug, more addictive. People that are crack dealers a lot of times are buying the cocaine and converting it themselves into crack. The conversion process is super simple. There's a couple different ways that people can do it, but mostly it involves just removing that hydrochloric acid. Usually people will do that by adding baking soda, which is a base. So they'll make like a paste of baking soda with water. Like maybe your mom would do that when you got stung by a bee, like put baking soda paste on you. So they'll add some baking soda with water, make it a paste, mix the cocaine in with it, and that baking soda will remove the hydrochloric acid, and then all they have to do is dry the cocaine back out. As it dries out, it solidifies into this crack rock. The name crack comes from the crackly sound that it makes as it's being formed and also as it's being smoked. And then there you go. Then you can take that crack, you can smoke it, and you can get a more effective high. I hope that by putting this video on YouTube that the authorities don't come after me thinking that I'm a drug dealer. I'm not making cocaine or crack. I'm going to stop talking now.